Thank you so much, everyone, for staying here the last day, almost the last hour, so I appreciate it. But the question is, who wants to learn about OpenTelemetry today? So raise your hand if you want to learn. OK? That's the spirit. OK. Today, we're going to talk about from HAR to OpenTelemetry trace in order to enhance observability. Before starting, I would like to transmit my message. So we want to improve our monitoring, debugging, and optimization of web application. Because we have the HAR in one side, but if we convert into a trace, we can take the observability backend benefits in order to debug it and improve monitoring. Let's go through the agenda today. We are going to start with an introduction about OpenTelemetry, about the HAR. So maybe some of you don't know what a HAR is. For sure, you have used it, but you don't maybe remember the name. And let's talk also about ThousandEyes. I'm going to explain all of those using a ThousandEyes use case. Later, I'm going to explain how we are really converting HAR into traces, our architecture inside ThousandEyes, how we are exporting those traces to our customer. Let's end with a demo so you see how the value is and with a lesson learned. So cool. You now know the topic that we are going to talk. Let's meet the speaker. As he mentioned, coming from Spain, working for ThousandEyes during the last years, and then specialized on the observability field. Let's go to introduction. If you don't mind scanning the following QR code, I would like to know what came to your mind when you hear about OpenTelemetry. Some people might think about observability. Others might also remember about open source. Of course, it is a vendor-agnostic open source framework that allows us to manage telemetry data. So you can collect all the telemetry data from your services, from your infrastructure, and then process that data and export it to the different observability backend and platform backend that today, this week, there were many on the booth, which is great. Thank you so much for those answers. So if I go now about my definition, it's an open source observability framework that to manage telemetry data. Today, we are going to focus on traces, but there are other signals like metrics and logs, and they are also talking about profiling, so stay tuned. I cannot talk about OpenTelemetry without talking about the collector. For me, it's like the main pillar of telemetry. It allows us to receive data in a variety of different protocols and formats, like Prometheus, Jaeger, OTLP, which is the OpenTelemetry standard format. But you can also query a Prometheus, or you can query a database, or read from a file, up to you. And then you process that data. Here, you can enrich that data, filter out. Also, you decide. And last but not least, you export that data to your observability platform. Or you maybe want to write it into a file. As I said before, it is up to you. You configure it. You make it. There are plenty of models already created by the community, but you can build also your own. It is on Go, quite easy. I encourage you, all of you, to do it. Let's talk now about the HAR. So how many of you know what a HAR or HTTP archive file is? So raise your hand. OK. How many of you have used it during the last week, the last month? No one, right? It is a tool that usually we use for debugging our web page, but in local. So when there is like a problem, so the support team asks you, like, can you send me your HAR so I can see what's going on there? So it contains all the interaction of your web page, like what is going on, all the requests that have been performed. And it's usually in JSON format, and it contains sensitive data like cookies, headers with the email, or maybe headers with your name or password. So things like that, bear in mind. It looks like that in general. So it's a JSON format that contains all the requests that are going when you are loading your page. So you're going to have like HTTP version. You're going to have like the method that was requested, the response code, URL, all that data are quite useful. Now let's move to ThousandEyes. In ThousandEyes, it's an application to monitor the network. It might sound quite generic, but that's reality. So we monitor the network all around the globe. We have agents in all the globe, like Cloud Agent, and then we have what we call Enterprise Agent, that we can have them in your own infrastructure, making sure that your network topology is working properly. It's in real time, because who wants to detect an outage first, your customer or you, right? So here it's a picture that I really like it, that describes how many outages are now in the world. like Monday.com, Microsoft in Belgium, so you can see how useful that tool is. Let's now emphasize on the page load test inside ThousandEyes. It is used to simulate what a web page will do when loading a page. So here we can find out like the time to load the page, the completion of that one, and all the requests performed to load that one. Here, it's the HAR, actually. So what you're seeing there is a HAR that we are representing as a waterfall, but that data is only inside of ThousandEyes. So in case you want to use it outside, like in your Grafana, in your Honeycomb, you need to convert it into an OpenTelemetry trace, and this is what we are going to do today. How is that transformation? So each request is going to be converted into a span inside of that trace. And that span is going to contain the following field. It's going to have a name that is going to have like the method and the target that we are targeting. The kind is going to be always client. Why? Because we are calling the server. We are calling the web page. So we are doing a request to them. We are going to have the start time and end time, which is key to understand when there is like performance issues. It is going to be like a status awk in case it was successfully, but the status fail if there was any error. And also, we are going to have the trace ID and span ID. Those are auto-generated by us. There was a session this week about semantic convention OpenTelemetry. Super useful. We use semantic convention because that gives extra meaning to the data. So we have for the span attribute, we are going to have like the HTTP request method, server address, server port about the host, the URL full, so which one was the URL that you were hitting, and then response code, super useful to know the problem. So we are using those attributes, but imagine if someone preferred to use like status code only or status code underscore HTTP. So if we follow all of us the same rules, the semantic convention is going to be useful, and it's going to add extra meaning to our data. And this is how the observability backend, the different platform receiving, when IBM is trying to receive it, they understand that this is a HTTP request with the following fields. Any observability backend. That's why it is that useful. You might be thinking also about the headers. So OpenTelemetry considers them as optional. The reason behind is because they might contain sensitive data, which is a risk to a string outside. As you might know, you might be thinking about redacted, but it might fail also. In ThousandEyes, we are not streaming those headers for two reasons. Risk about sensitive data, and they might become quite huge. And what we are interested in is on understanding the performance issue, not really the header that went sent or not. And let's finish with the resource attribute. A resource attribute, for the people that don't know them, is a way to identify the resource producing that telemetry data. So here we are going to identify the resource as ThousandEyes, the test, and the agent running that network test. So we are going to have your ThousandEyes account ID, your test type, name, and ID, and also the agent that was running. Here we're going to have information like the agent name, agent location, agent type, all those things. And then a permalink, because it's super useful when you are debugging a problem, you identify the problem, but you're going to need to jump into ThousandEyes to have the whole picture, the whole overview about that issue, about that network issue. Let's jump through the permalink. So we already know how a trace looks like. Let's see an example. Here we're going to have all the resource attribute, all the spans. For each span, we're going to have like the time, the name, the span attribute. And then this is just JSON, but when you realize how useful it is on your observability backend, you're going to need it. Let's jump now into the architecture. I hope it's not really deep, but you get an understanding of how we are using it. In ThousandEyes, we have our agent generating all the test data. All that test data contain the HAR. And then we are receiving our trace collector. So we are using OpenTelemetry collector 2 in reality. The trace collector process all the data, and it's sent to the integrations collector. In the integrations collector is where we are routing, like that data point is going to go to that observability backend. That data point is going to go to the other one. How we know that? The user decide like all the telemetry data from that test is going to go to that observability backend, and they are creating an integration to make that connection. Let's zoom in a little bit. Here, the data is received from Kafka, as I mentioned, and we are converting it right straight from the HAR to our OpenTelemetry trace. Later, we go to the processor, and we filter out the data, because here you can imagine that ThousandEyes is running thousands of tests, millions of tests, with millions of agents. So we need to filter out the data that is not going to be sent anywhere. Why do you want to process? We are going to enrich that data on the attribute processor. So we only receive the test ID, but we want to know also the test type, the test name, also the agent location. All that data is super useful to know if the agent is coming, and the problem is only on San Francisco, but not in Spain. You need to know that information, right? And later, we are going to batch it for performance reasons. We export it to the integrations collector. The integrations collector is going to process that data. When they process, imagine a data point is going to go a destination to observability backend for redundancy, because you are doing a migration for any reason. We need to duplicate that data point, plus adding a new attribute saying integration ID. Because on the OTLP routing, which is an extension of the OTLP exporter, what we do is, okay, we decide that integration is, that data point belongs to that integration is going to go to that observability backend, let's say Grafana. That the other one is going to Honeycomb, the other one is going to IBM Instana. So you're going to realize that we need to route that data. Let's take a look back. We also have the concept of extensions in the collector. Extension and components that are accessible through all the modules of our collector. And here we have like the health check. So in Kubernetes, you need to know when your collector is ready, so the production readiness, the check readiness. You also need the storage. We are getting all the data from our metadata service, all the integration, all the tests, all the agents, and we are storing it there in a cache. Later, we have the event bus. This is a PubSub system that we are publishing data and we are receiving from other components. Like every time that data point is filtered out, we are sending that PubSub system. And then in the metrics collector, in the metrics extension, we are receiving that event and then incrementing a counter. We have also the sentry. It is used to every panic or every error in Go, they are sending to sentry. And then the metric is like we observe our own observability system. So we know all the metrics about filtering data out, data received, data sent and export, and so on. Something that I would like to highlight that I forgot is, why do we have two collectors instead of having one? First one, of course, like they are different business domain. The first one is the trace domain, like processing the trace data and converting, and the other one is the integration. Also, they scale at a different pace. So integrations collector scale depending on how much data we receive from our test, and the integrations collector scale depending on how many integrations the user have created. Let's go to demo. Let's go to the fun part. So we are going to create a ThousandEyes test that is going to go to Cisco.com. So it is going to load the Cisco.com web page. And that ThousandEyes test is going to give us all the the time that's required to run that page load in Cisco.com, also the completion, errors like timeout, and then we are going to have, of course, our HAR. The HAR is going to contain, as I mentioned, all the requests needed to load that web page. But that data just lives in ThousandEyes. But if you need that data in other places, you don't have it. That's why we are using OpenTelemetry traces. So now we are going to go to create an integration to decide, OK, the data from that test, I want to send into Jaeger. So I go to OpenTelemetry integration. I select my target. I select the type traces. I select the test, and then just create it. And now all the data is going to flow to Jaeger. In Jaeger, you have the capability to visualize all the traces, and this is how a trace is going to look like. You're going to have all the requests appearing there as a different span. And for each request, you're going to have what we mentioned before. You're going to have the resource attribute, which is going to identify ThousandEyes, and the span attribute, which is going to identify that specific request, like the response, response code, and the HTTP method. All those things are going to appear there. Let's also take that screenshot that visualize only a single span, and we can go one by one. In the tags, we are going to have, as we mentioned, the request method. Like in that case, it's going to be a get, response code 200, server address that we are hitting on the server port. And then we are going to have the kind and the URL. That is for that single request. That information we are going to have for every single request. And then for the process tag, as it's called in Jaeger, but they are the resource attribute, it identifies ThousandEyes. So your account ID, your data model version, the permalink, your agent, your test, all that information is there. Okay, that's cool, but how do we take advantage? So each observability backend is going to have their own benefit. I just used Jaeger for that demo, but here we're going to have things like, let's only serve for traces, which mean like page load, that are having errors. And then you're going to see all the traces that are having errors. How useful is that, right? And then you go there and see, okay, there was a bad request when loading that Cisco.com in that specific span, in that specific request. And now you're going to see what your customers really are facing. But another use case is timing. Why some page loads are taking 5 seconds, why others are taking 7? The cool thing about also observability platform is like you can compare 2 traces. You can say, okay, that trace took, as you can see there, 5 seconds, and the other is taking 7 seconds. Such a big difference. Why is that happening? So you go there and compare it, and you see that there were 210 spans on one side, but there were 245 on the other side. Why are those different? So you can go now one by one, understanding why those requests were different in different time on our system. I would like to end up that presentation with a lesson learned about that project. Tracing. Everyone is talking about microservices, how they are connected to each other, but there are plenty of other use cases. This is just another use case. We can convert a HAR into OpenTelemetry trace and debug it. OpenTelemetry. There is a huge community behind working forward to make it better. So they were quite helpful. You can make questions to them. You can create GitHub issues. We even contribute in a couple of issues that we have discovered. And the OTL collector, we were having a session before talking about the collector. It's a mature product. It's hard at the beginning to start, like creating a processor, creating a receiver. It's really hard. But once you create some of them, it's glued together perfectly. I mean, it's worked really well. I really encourage you, all of you, to try. And the last but not least, what was our key message at the beginning? We want to improve monitoring our system. We want to identify error the first. And we want to have more insight of our web application. Thank you so much for your time today. I hope it was useful. Let me know if you have any questions.